Hi all. So today we will be working on LLD. So I have prepared a list of questions which I'll work on for LLD preparation. So let me just open that list here. Yes. So this is the list I am planning to work on. So basically, we would go through each of these problems one by one, like in one by one in videos. So today we are focusing on parking lot problem. Okay, and for any problem, we have a specific framework. Okay, which we can follow, right? So the framework is this basically. Okay, so we can write it more clearly basically. So one very important first point, let's write it in numbered bullet format. First point is requirements gathering. Okay. First point is requirements gathering. Especially in LLD, we can focus on the functional requirements. We can we can focus more on the functional requirements. Okay. Then what we have to do is, once we have identified the functional requirements, we have to identify the core entities. Identify the core entities. Basically, the entities around which your code will work. Okay, and then we identify the relationship among the core entities. Okay, it would also involve working on figuring out the attributes and the necessary methods. Also, at this step we will prepare the class diagram. Now this class diagram is something which the interviewer may or may not expect from us in an interview, but anyways, like, since right now we are preparing, we will prepare for all the necessary stuff. And also, what I've noticed is, if we have prepared a class diagram, our coding becomes very easy, because after that you just have to translate the design you have prepared into the code, and this steps becomes very easy if we have done this step nicely. Okay, these steps are actually very important. And after that, what we can do is, we can discuss the design patterns used, and what the improvements, what are the improvements we can do on the system. So requirements gathering, yeah, right. So this is these are this is basically the framework we would be using when we are solving any LLD question. Okay. I'm just trying to think if we can add a step before this, which would be, understanding the user flow. Or let's say, see, this is not this is probably something which you have to do, within your mind. If we have been given a question, like, let's say today we are working on design a parking lot, right? So within my mind, I should be very clear how a parking lot works, right? So something, let's say, use use case, or let's say system flow. So system flow should be known to me very very well. Okay, so this is something I'll do, uh, you know without, maybe, like, we can also, check with the interviewer that, okay, is this what you're expecting. We try to ask for the system flow, that what would happen on the system. Either we can ask this, or it can be a, implicit step we are doing ourselves. Anyways, but from these steps, all the up to this step, everything is mandatory. Okay, so yeah, now let's start working on design parking lot. Okay, so let's think of the first step, which is the system flow of a parking lot. Like, what will happen at a parking lot, right? We have to be clear with that. So basically, what happens is, a driver, or user basically comes to the parking lot. Now at the parking lot, they get a ticket, or basically they look for a spot. Okay, And if we are talking of a multi-level parking lot, like huge parking lots like in shopping malls, so they have there are multiple floors, right? So they look for a floor. So first they will look for a floor, and then for a particular parking spot. Okay, and they will park their car there. Now again, this parking spot depending on their vehicle size, right? Depending on their vehicle size, which means for different vehicles we can have different parking slots, spot or slots. Okay, so a driver comes, they look for a floor, and then they look for a parking slot, and then they park their car. They park their vehicle. After they are done with the parking, and basically, let's say when they are leaving, they would pay. They would pay at the counter, right? This is what happens when we, go to park our bikes and cars. We pay at the counter. Now we have different payment options available. Different payment options available, like cash payment or card payment. We can support multiple payment methods. Also, UPI payment, something like that. Other than that, what we can think of, they look for a floor, then for a particular parking spot, depending on their vehicle size, would park the vehicles, they would pay at the counter, and we have different payment options available. Yeah, okay. And one more point is that, they park their vehicle when we initially enter the parking lot. We are given that ticket, right, which we have to keep with us, and after we leave, basically when we are leaving, we give that ticket, and they figure out how much we should pay, right? So, and they park their vehicle and get a parking ticket. So we get a ticket which has the entry time noted down, right? Our entry time is noted down there, and then when they are leaving, they would pay at the counter. And different payment options we can support. We have to pay, different payment options are available. And yeah, so this is basically the system flow, right? Now when we are done with the system flow, as per our list, the second step was requirements gathering, which especially refers to uh, functional requirements. So let's note down the functional requirements. Now in this step, obviously your interviewer would help you, because yeah, obviously they would help you, they would tell you the requirements, right? Only then we would be able to implement it, correct? So uh, let's work on this functional requirements for parking lot. Okay, to write the requirements, functional requirements, we can, go through our system flow. That would help us in understanding what all stuff is required. Okay. So see, when we are saying they look for a floor, it means we have multi-level parking lot, right? So which means the parking lot should have multiple floors. Okay. The parking, each floor should have multiple parking slots or spots. Let's go with slots. Okay, then what we can say is customer collects parking ticket at the entry, and customer for the pays or let's say does the payment at the exit. Okay, so we have payment stuff. Then we can support different payment options. Okay, or multiple like cash payment and card payment and stuff. Okay, then what we can do is right, different vehicles can be parked on the basis of parking slot size, right? So we can have different types of parking spots, this means. Okay, and then then what we can do is, yes, so when they would pay, right, it would calculate the duration as well as the, we can have different rates for different vehicles. This is also important. Okay, we may have different, like, let's say, $20 for truck, $10 for car, and $5 for bike, something like that. So when we are saying different vehicles can be parked, that, let's say, we have mentioned that we have three types of vehicles: car, truck, and bike. Okay. Okay, so we will have different parking lot sizes as well. So pieces, so different parking lot sizes are supported. Okay, other than that, can we think of anything else? One more point which we can add is that, you know uh, the payment or amount is calculated by the duration and the size of the vehicle, right? Or let's say the parking slot. Okay, other than that, i think I think these are good enough. We have figured out all the functional requirements. Okay, uh, so for the sake of LLD problems, we could just say that we have gathered all the requirements. Let's not go into the functional, non-functional stuff. Okay, right. So now what we have to do is, we have done the first step, which is a very important step. Now what we have to do is, we have to uh, work on the core entities, right. This was our next step: identify the core entities. Let me just check. We are not missing any step, right? Mm, System flow requirements, yeah. So we have to, let's go to this, and we have to now identify the core entities. So let's identify the core entities. Now, to identify the core entities, what you can do is, you can go through your requirements one by one, and you will be able to figure out what your core entities are. It is very simple, actually. Okay, so first, if you see, we are saying parking lot should have multiple floors. So what we can have is, we will have a parking lot, right? We can also have parking floor, and then each floor will have some slots, so we can also have parking slot, right? We can do something like this. Other than this, we would have a parking ticket, because we are giving tickets to the customer. Then we have different payment options. So we would have something like payment payment we can say, let's say, we can have UPI payment, or we can have cash payment. We will support all this. So to support all this, we would use the strategy pattern. Okay, so we can touch upon strategy pattern when we are actually writing the code. So payment is strategy, UPI payment, cash payment. Payment is strategy would help us in understanding which payment method to pick. And see, we have two payment methods. So we will have a interface for payment. So this is an interface. Okay, payment interface. It will have the cash payment and UPI payment as its implementations, and payment strategy would get us the payment method. Okay, other than that, we would have a vehicle entity, correct? Because vehicles would be parked, so vehicle entities required. Then what we can have, different parking slots as a support, different rates are there. Should we store the rates somewhere else, or basically for vehicle only we can store the rates? Let's see. Um, okay. So one more thing, that we are keeping vehicle, so we can also have car, bike, truck as the subclasses. So we would have car, bike, truck. So basically, as of now, I'm supporting these three types of vehicles. Okay. So we have to write our code so that it is modular, and it can be extended to support different types of vehicles. Let's type this. Okay. And we have a payment strategy. All this is good. Uh, okay. Yeah, I think this is good. Okay, this is good. uh the rates, basically I was thinking where we can, you know, store the rates for the vehicles. So either that can be, you know, uh, where should we store the rates? So either we can, you know, specify the rules inside payment class, you know, because payment class would do the calculation. Okay, let's you know, we'll think about it when we move to the next step. Let's not get confused. So the next step is identifying the relationships and actually creating the uh, class diagram. So identifying relationships, attributes, and methods, and actually drawing the class diagram. Okay, so class diagram. So let's start working on this step. Okay, so now we are working on the you know, identifying the relationships, attributes, and methods, and then the class diagram. So I have opened up a plant. You know, this would help us in drawing that, you know, class diagram. So okay, let's go through this. Should I zoom in? I think I should zoom in a bit. How to zoom in? I think this is fine. This is fine. Yeah. Okay. So first core entity we have is parking lot. Okay. So let's just say class parking lot. Now we have to write in here what all methods, what all you know, attributes and methods will this class support. Class is parking lot. So what all stuff can be supported? If we think about it, parking lot can have a name. Let's say, you know, we can have a parking, we can have a name for our parking lot, right? Or let's just say we are going with a ID for now. Okay. Other than that, we can have some location or address for it, parking lot, for the parking lot. Okay. Other than that, we don't want any, we don't want any attribute here. I think this is fine. Parking lot, parking lot will have this, and also parking lot. Basically, you know, these are the attributes. Now, what are the methods we should support? So when we, you know, let's say, let's think from, you know, let's think in a like how would we create a parking lot? When we are creating a parking lot, we would add some floors in it, right? So we would need a method like add parking floor. Okay, and it would return rule. Or okay, so our parking lot can also will also have a list of all the parking floors. Let's say, okay, parking floors. So it will have a list of parking floor. Okay, so we are doing add parking floor. Then we can also have remove a floor, or let's say it's not really required, or we can also add it anyways. Okay, so we have a list of parking floors maintained in the parking lot, and then we are seeing add or remove. And other than that, what else stuff can we support here? Okay, we'll come to it. Okay, let's move to to parking floor. So now we have a parking floor. Okay, now every floor will be identified by the level, let's say, and it is a integer. We would have at max, you know, 10, 12, something like that. So integer is good enough. So every parking floor has a level. Okay, then it would have a level, and inside here we can write something like, now since parking floor would contain the parking slot, that is why here I am giving parking slot, and here I can maintain a list of parking slots, okay, available parking slot. And here I'm saying add parking slot. Okay, again I can add or remove. So basically, you know, remove can be a scenario where suppose a slot is, you know, is in maintenance state. Then let's say we are trying to remove that slot. Okay, So yeah, we will have add parking slot. Then let's go to parking slot. What all things should we support in a parking slot? So first, a slot, let's say we would have an ID. ID is very important to uniquely identify the slot. Okay. Then we should also maintain what is the size of the slot. By size we mean what you know what type of vehicle can it uh, park. Okay, what type of vehicle we can park there. Okay, so what we can do is um, let's say we would have, okay, so let's do one thing. Let's create an enum. Let me check how to create an enum. So we can create an enum for parking slot type. Okay, so I can just write it like this: enum parking slot type. Now we can have large and small, and or let's say rather than saying large small, we're saying car slot, and we say bike slot, and we say truck slot, because for now we are supporting only these three parking slot types. Okay, so yeah, here we were, and now we have an ID. So we would also have a type. What is the type of this parking slot? And then we would have a boolean which would say if the parking slot is free or not. Okay, or let's say is it available or not. That sounds good, better than free. So we would have a available stuff. Okay, then so basically, when we are trying to park, we would need this stuff is free. We have to verify if the parking slot is available. Let's say is available. Okay, this is a helper method. Uh, right. Other than that, what we can do is, right. So let's say when a vehicle comes, right, we would want to check if we have any slot available or not. So let's say we have a helper method here which would let us, which would tell us that. So we can have a helper method which would say that uh, parking full is parking full, because if parking is full, we won't have any slots and we cannot, uh, park the car or park our vehicle. Okay. So this is good. This is good. Parking floor also we can check. Uh, is parking floor full? We can have this implementation. We have is available implementation here. Okay, so we are done with the first three stuff. Let's try to generate the YAML. Okay, it looks something like this. If we open it in a new page, it would look better. Okay, anyways, let's continue and then we will work on this. Oh, let's continue. So now we are coming at parking ticket. Parking ticket is also very important. So let's work on parking ticket. So what are stuff do we want in our parking ticket? First is obviously it would have a unique ID. Parking ticket would have a ID. After that, a parking ticket would have an amount as well, right? After that, a parking ticket would be assigned to a vehicle, correct? So should we maintain the vehicle here? Let's say, see, for a parking ticket, we would store the entry time of the this of our vehicle, correct? Should add, and one would be the duration, or let's say issued at. So we need two things to calculate the amount, right? One is the vehicle and the rate. Okay, so the rate, can we store the rate here? So for parking ticket, we are going with IT amount issued. Okay, I think this is fine for a parking ticket. We can also have maintain a status. Okay, parking ticket status. It could be, basically if a ticket is paid, so we can maintain two things. The ticket is either paid, or the ticket is, okay, I don't need to give the commas. So the ticket is either paid or the ticket is active, or let's say it would be paid in some way. Okay, something like that. So we have this parking ticket and all that stuff. Now let's move to the payment thing. Okay, that's good. Let's move to the payment stuff. So we would have a class payment. Payment is actually not a class. Payment is an interface. Okay, and it would have it will have the amount, right? So it will have the amount, and it will also have an interface, or basically, sorry, a method which is process payment, which will handle the payment stuff. Voice. Okay. So process payment, I think, would take in some inputs. Let's say. Okay. So we have a class which is UPI payment, right? We have this class UPI payment. So uh, we can just do the UPI payment actually. Basically, UPI payment would implement this method given in the interface, and also similarly cash payment will also implement the method process payment, something like this. Okay, and then we have a payment strategy. So we have a payment strategy which will have a static method to pay, something like that. So let's say static method, I'm not sure how to, I think we can underline to show that it is a static method. So we would say pay, and it would return void, and in here I can say it would receive a payment, uh, payment method payment. Okay, and this is a static method. So let me just underline, sorry, what did I do? I want to underline it. How do I underline it? I'm not sure, but yeah, something like this. I'm not sure. Let's see. I'll check that and I'll do. So yeah, we have a payment strategy. Other than that, let's work on our vehicle class. We haven't yet implemented the vehicle, right? Yes. So let's work on the vehicle class. So for whatever vehicle we get, we can have its license number in a string, and we can have the vehicle type. So again, vehicle type, we can say something like this. So in vehicle type is vehicle type would be car, sorry, car, car, bike, and truck. Okay, this is the vehicle type. Other than that, see, when a vehicle comes, we have to assign it the ticket, right? We have to assign the ticket to vehicle. So every vehicle will have a parking ticket as well. Got it? Because I mean, it can be null for vehicles which haven't, which are unable to park. But see, okay, I think this is what we will maintain a ticket here as well. So we are associating a vehicle to a parking ticket, right? Which is, I think, fine. And I think this is good. Okay, let me just check it once if we have some changes to do. So till now, what we have worked on is the attributes and the methods. Okay, but we have yet not touched the topic of relationships. Right now, if I make this full screen, okay, if I try to regenerate this, you see there is no relationship, there are no arrows, correct? So we need to implement the relationships now. Okay, so let's start working on that. I don't know why it is coming so much stretched. Why is it so much stretched? This is fine, I think. Screen refresh, pop out. What is pop out? Okay, the image is popped out. Okay, this is also fine, I mean, but I think that was better. Let me remove this pop-up thing. And where is the image? Scale. Yeah, this is fine. Here it is coming side by side. This is good. So let me now work on the relationships. Okay. So now you see a parking lot will have multiple floors, right? We can see it inside. So let's add that. To add that, we can say parking lot can be one, and we will have multiple parking floor. Okay. So it is a contains, like a parking lot contains multiple parking floors. So you see this. You see this. This arrow is now created. Parking lot. Should I write it like parking lot to parking floor? No. Okay, this is what comes inside there. Okay, okay. So let's just write contains. Okay, this is fine. This is fine. Then let's move ahead to that a parking floor would have multiple parking slots, right? So parking floor is this, and parking slots can be one to many. So parking slot, yeah, okay. And this is again a contains relationship. So we can do this. I hope this the last line is visible, right? Yeah. Okay. So now this is prepared. Now what we can have is so a parking slot. So this is an enum. Parking slot type is enum. I'll just say parking slot to parking slot type. Okay, this is just a type. Okay, then we can say that vehicle. So we are saying that each vehicle may have 0 or 1 ticket, right? It can either have 0 or 1 ticket. So then 0 or 1 parking ticket for the vehicle assigned. So now where is our parking vehicle? Yeah, so vehicle. So we assign a parking ticket to each of the vehicles. Then we can say parking ticket to parking ticket status. Again, this would be status. Okay, this is just the enum. So enum stuff is I think easier to understand. Then we have vehicle to vehicle type. Again, this is type. Save and refresh. Vehicle to vehicle type. Okay. Then we would have, so a payment is always tied to a parking ticket, correct? So parking ticket to a payment. I mean, it's not really required to write all that. I'm just, trying to understand the stuff entirely. So this is how it is. And basically UPI payment and cash payment, they implement the payment interface, right? So let's say, yeah, cash payment. Let's see, payment. Where is the payment? Yeah, so UPI and cash payment are implementing the payment interfaces. So for implementing, we can give something like that. Dot dot means dotted arrows, and this means a reverse arrow to that side. Okay. And then we have the payment strategy. So payment strategy to payment uses, because payment strategy use the payment. Okay. Okay. I think this is good. What happened? Yeah, this is good. This is good. We have connected all the components. Right, right. Okay. I think this is good. Give me 1 minute. Okay, I think we can move to code, but let me just review it once. I think I have not added enough methods in here, right? Uh, we have added the added the important methods, but probably not all. Um, okay, so basically, when we would assign a parking ticket, or basically, let's say when a vehicle comes, we would create the vehicle, and we try to assign it. Basically, we would create a parking ticket, right? So we create a parking ticket based on the vehicle's time. I think there we are missing some methods, but I think this is good enough for now. I think we should move ahead to the next steps, and then we can do some changes as required, as and when we identify them. Or should we give it a think? We can just probably give it a thought once. Here also, I think I can add the arrows. So parking floor would be, yeah, this basically we have a relationship here. Now this should be actually a diamond, because this is a composition. A parking floor cannot exist without a parking lot. How to show composition in UML? I want to show a composition because a parking floor cannot exist without a parking lot. So it is showing something like this. Okay, okay, this thing now. So this thing, okay. Save and refresh. What is wrong here? It is saying car its wheels also cease to exist. The filled diamond is placed on the car end of line, replaces multiplicity. What is wrong? What is wrong? Okay, let me check once. Give me a minute and I'll fix this. Okay, so I've done few changes after referring to ChatGPT, which is here we have incorporated, the relationships like composition, aggregation, and association. So if you look at this, basically a parking floor cannot exist without a parking lot, right? That is why this is a composition, and this is a very, this is called a strong ownership. Okay. So here, if you see, we have a filled up diamond. Filled up diamond for the same is valid for parking slot as well. We cannot have a parking slot without having a parking floor. Correct. Other than that, we have this is the composition relationship. Other than that, we have an aggregation relationship between parking ticket and payment, which means they have a weak relationship. Like they can exist. Basically, we can have a payment method without a parking ticket, right? We can have that scenario. We may want to store all the payment related stuff. So that is right. They are not strongly dependent on each other, but there is a relationship. That is why this is an aggregation relationship. Okay. Other than that, the other stuff are basically normal association stuff. That's it. And one, this is inheritance, which we have already identified earlier. Other than that, what change I have done is I have identified the static method. For static, it comes as underlined. That is why I have made it static. One more thing is our parking lot. Parking lot would be a static, would be a singleton method. Okay, basically we are trying to make our parking lot a singleton so that we cannot have multiple instances of parking lot. So for that, I have made it static. Okay, basically get instances static, and its constructor would be private, as in a singleton design pattern. Okay. Now I think we are at a very good position. We have identified the requirements and stuff. We have prepared all this, prepared the class diagram and everything. I think we can jump into the coding for this. So I have exported the diagram which we created, and now I'll use this when writing the code for my system. Okay. So we can get started with the code, and we can start by implementing each of the methods at the classes. So let's get started. First one is parking lot. So we can make something. We can make a class parking lot. Okay. Now, uh, yeah. Okay. So what all attributes we have defined is ID, address, and parking floors. Okay. So we would need parking floor as well, and parking slot as well. Let me just prepare all of them in a models package. Okay. So now we would have parking floor. Don't ask again. Add. We would have parking slot. Then we can have basically one more thing here. We were using parking slot type. This is an enum. So for enum, you can maintain a separate package. Now, see, in interviews, you don't have to make these many folders and stuff, right? You would simply write the code. This is just for for our understanding how we are maintaining the stuff. So parking slot type. Okay. So enum would say car slot. I think this comma is not bike slot. Okay, comma is required. Sorry. Then we have truck slot. Okay. So these are the parking slot types. Now let's go to the parking slot. So for each of the parking slots, we have identified an ID, type, and available. And this basically red stuff means that these are private. Okay. So private long ID, private string, sorry, private uh, parking slot type, and private available, sorry, boolean available. And this can be by default false as well. So I've assigned a default value to it, which is false. Anyways, for boolean variables, default value is false. We can have a constructor. So the constructor for it would create this, and okay. So when we are writing the constructor, we would assign, basically when we are creating a parking slot, we would assign ID to it and a type to it, right? So we need to take the type from the user, right? Suppose when we are creating a parking slot, we need to know which type of parking slot do we want to create. Okay, so we can just say something like this, and then we would say this dot type is equal to parking slot type. Available is anyways false. Let's just uh, let's just see. Okay, sorry, available would be true, right? We have created a slot, so it is available for parking. And what is its ID? So for ID, basically what you can do is you can create an ID generator. So what my implementation usually is for IDs is that I use this bit. Let me just tell you, let me create a utility package. In there, I will create a new class ID generator. So in ID generator, I will implement a public static method because I don't want to instantiate or create an object of this class, and it would return long. And we would say get, or let's say generate ID, generate unique ID. So here what we would do is we would do a very simple thing. We would return the current time in millis, current time in milliseconds. So this would automatically be unique, right? Whenever we are creating a class, sorry, an object, we would get a unique timestamp, and that we are assigning to the ID. Okay, so we can say ID generator. No, sorry, we can say generate unique generate what happened? ID generator dot generate unique ID. Yep, okay, no problem. So we are able to, now we have created the parking slot. So let's just also we can take a look here that we are not mentioning the constructor when we are defining our classes or the getter setup methods. Okay, so we have a is available method. So let's implement that. Public boolean is available, and we can say return is not available. Okay, we have implemented the parking slot class. Now we have to implement the parking floor. So let's go to the parking floor. parking floor, what all stuff do we have? We have a level and we have a parking slot. So let's implement int level, then private list of parking slot. Okay, some parking slots. Okay, so we can have a constructor. So constructor flow. Basically, what we would do is we would instantiate the parking slots in array list. Yeah, this much is fine. For level, I was thinking that we can make level as static. Okay, so that whenever we increment level, that is at the class level. Okay. I think this would work. So its level would be basically this dot level will not mean anything now. Level would be level. Yeah, that's it. So now level would keep on increasing whenever we are creating a parking floor. I hope this should work. Okay. Other than that, we implemented add parking slot, remove parking slot, and all that stuff. So let me just write those functions. Public for all of this, return type is boolean, public boolean, add parking slot. So we will get some parking slot. So we would say this dot parking slots dot add. Okay. So basically, for each parking floor, we are having parking slots. Yeah, I think this is fine. Control, remove parking slot, or click boolean, remove parking slot, getting a parking slot. So if this dot parking slots dot contains parking slot, then we do what we can remove. So this dot parking slots dot remove. Okay. Other and we can return. We can return. Else we can return false if it doesn't exist. Okay. Other than that, is parking floor full. So yeah. Public boolean is parking floor. Is parking floor full. So now to check if it is full, it means that none of the slots in it are available. Okay. So this is slot available. Let's make it false. Okay. So now we can iterate through for parking slot in this dot parking slots. If sorry, we have to also give that variable, right? Yeah. So now if parking slot dot is available, then we would say slot available. And as soon as we find that one slot is available, slot available. As soon as we see that one slot is available, we can say return true. Okay. That we can return false, which means that okay, the parking floor is not full. Parking floor is not full. Okay. So return false. Otherwise, we return true. Okay. Actually, we don't need the variable if you look at this. We are simply checking if parking slot is available, we return false. That okay, parking floor is not full. Otherwise, we return true that it is full. Okay. We can probably also add parking floor with level is full. In here, I can say this not full. Okay. So, yeah. Other than that, what did we say we would implement? So this is fine. This is fine. Now let's move to our parking lot. Sorry. So for parking lot, we have an ID, private, long ID, private string address, and then private Okay, private list of parking floor. Okay, parking floors. So in here again, okay, now here I'm trying to make this method singleton. Singleton would basically mean that we want only one instance of this. This is basically the controller. Okay, this is basically the class which would manage all our components and all our stuff. That is why I would make its constructor as private. Okay, we can make the constructor as private. That means its constructor cannot be called by an outer class. Okay, it would take in the address thing. Okay, and now it would have a instance thing. So let me write private. Instance will also be private. Okay, private static. The instance will not belong to the object rather than to the class. Private static parking lot instance. Okay, and then here we say public. So now our get instance method needs to be public and it would return the parking lot class, right? Get instance. Okay. So now here we would say if instance equal to null, then we would instantiate. So we would say instance is equal to new parking lot, and then we would have to send in the address, right? So I would need the address in here. Okay. Otherwise, we basically would just return the instance. Okay. So this we have created a method. Now this method is not thread safe. Okay. But right now I'm not going into those details of singleton design pattern. Okay. You can go through singleton design pattern. We have 4 to 5 implementations of it. Okay, I'm going with a lazy initialization method. This is not safe, thread safe. For thread safety, I would have to write this keyword here, but then this is a slow method to do it. So there is a better method which is double check locking, and further there's a much better method which is build per singleton, but I'm not going to any of those. Okay. So yeah, we have done this. Here we would say again, let me just reduce the utility. Okay, and here I would say this address is equal to address. Okay, so this is good. Other than that, what did we say? We would implement parking floors, add parking floor, remove parking floors. Let me add those public boolean add parking floor. So we need an input parking floor. So this dot parking floors dot add parking floor. Another thing is in here, I will also have to instantiate the parking floors list. New array list. Okay, this is fine. Now we are saying add and we don't in here also make a function with new parking floor. Let's say parking floor. Sorry, parking floor. Parking floor. If this dot parking floors dot contains parking floor, this dot parking floors dot remove parking floor. Okay, and if we are able to remove, return true, otherwise return false. Okay, this is fine. Now this parking full. Okay, so we can implement an is parking full functions is parking full. Okay, now here we are trying to check whether our parking has some available space or is it full. Is it full? Okay. So for is parking full, what we can implement? Let's say, okay, what we would do is we would go through each of the parking floors. Okay, this dot, sorry, we are just write parking floors. If parking floor dot is parking floor full, or let's say if not it is full, then we can return false, that it is also not full. Otherwise, we can return true. Okay, this is done. So we have implemented this part entirely. Now let's move to vehicle thing. Vehicle will have a parking ticket, so let's implement the parking ticket first. Okay, so we have another enum which is parking ticket status. This is an enum. Okay, so it is paid or active. So by default it will be active. Now we have a parking ticket. Implement a parking ticket plus parking ticket. So for parking ticket, what we are doing is private ID, within ID, we have the amount, we are saying local date time, issued at, okay, and then we are saying status, private parking ticket status, okay. Now we can have a constructor for creating a parking ticket. So let's create a parking ticket. So when we are creating a parking ticket, we would say this ID is equal to ID generator dot generating the ID, this dot amount. So initially, so basically when we are generating a ticket, right, we don't have any amount. Okay. For now, let me just set it to 0. We can later analyze if we need this stuff or not. This dot issue that will be date dot now. I hope that exists. Wait. Date. I don't know. Date dot now exists in JavaScript. This dot issue at. Okay, let me check this real quick. So this is local date time dot local date time dot now. Okay. So this dot issue that is done, and now this dot is status. So initially status will be active only. So status dot active. So this is how we create a parking ticket. Okay. Other than that, what are we associating in a parking ticket? Nothing. None of the methods. Okay. Now let's create a vehicle. For that, let me also create a vehicle type. So vehicle type. So again, we can have car, bike, or okay. And we have, yeah. So let's create a vehicle. So for a vehicle, we have a license number, private string license number is there to uniquely identify a vehicle. Then we have a type. So say private vehicle type, this type. Then we have a ticket, parking ticket. This. And now what we do is when we create a vehicle now, we would get a parking ticket. Let's see if there are any changes we would have to incorporate. And one thing is we would also get the vehicle type. Okay, so we would say we would also require the license number in here. Say this dot add values for the values. This dot license number is license number. Type is type, and this dot ticket is ticket. Okay. I'm a little unsure if when we create a vehicle, we would assign the parking ticket then and there, because let's say a vehicle comes, okay, and if it is full, then we won't allow it to enter, right? Right. So would we create the vehicle object? Let's see. So this is done. Now let's implement the payment strategy. So this is the strategy pattern which we are handling here. Let me implement the payment strategy. I'll create a separate package for it. Let's call it strategy, and inside it we would have a class payment strategy. First, we should implement the payment interface that would help us. So let's implement the payment interface. So inside the payment interface, there's some amount, private double amount which is being paid, and then we have this method process payment. Sorry, So interfaces cannot have variables. So this is wrong in our design. Interfaces cannot have this. If it was an abstract method, then it could have the amount thing. So we won't have it here. Okay, so we will have process method. So let me just write about that. Public void process payment, and this will take the amount. Okay, so yes, this is a abstract method. Okay, now it's redundant, so let's just avoid writing it. So now let me implement cash payment. Cash payment. Cash payment will implement payment class. Okay, which means it should for sure implement that method. Let me just implement the method public void process payment. Okay, double amount. So we will just say here we don't have a business logic. Basically here business logic should go in. So processing cash payment amount, then we get the amount. Okay, this is done. Okay, okay. Similar entirely similar stuff we can do on the UPI payment stuff. UPI payment, implements payment. Here we would go and let's just copy this part. Let's just implement this. Okay, so these are implemented. Now let's implement a payment strategy. So inside a payment strategy, what we would say is we have a static method. Public static void pay. Okay, so here it would take a payment. Okay, and it would say based on the payment switch payment. Sorry, switch payment is wait. So here we would take the right. So basically here we will take this user input, right? So basically user would decide whether they want to go for a cash payment or UPI payment. Okay, so let's say we would get a string here, okay, of payment type. Then we can say switch, okay, and also the amount. So user would say that this is the amount I have to pay and this is the payment type. Then we would do switch payment type dot to lowercase. Okay. Now we would say case payment type equals to cash. We have implemented cash, right? Then what we would say is, okay, let me implement this payment. Okay, so we would say payment is equal to new cash payment, and inside cash payment we would set the amount, right? It's wrong. Default constructor is invoked with arguments. Oh, right. My bad. We have to call the process payment method and nothing, not the constructor, right? So what we can do is, would say, okay, give me a minute. Let me just think through it. Okay, so this is the correct implementation, I believe. What payment type should come would be handled at the caller, client code where we are calling this thing. Yeah, I believe this is correct. Okay, let it be. Okay, this is correct, I believe. Let's move ahead. Let's see. So we have implemented all the stuff. Okay, now we can write our main class. Right. Let's say parking lot system. Call it this. Let's just call it main. Okay. So main is basically the driver code. Okay. Public static void main string class. Okay. So first and foremost, we have to create our parking lot. Say parking lot is equal to parking lot dot get instance, right? address is, let's say the parking lot is in, let's take a small area which is Whitefield. Okay, this is just the address. Okay, nothing else. Now we would add some floors to it, right? So let's create parking floors. So parking floor one. So I'll just create two floors. Okay, so parking floor one is uh let's create parking floor one. So let's say new parking floor. What does it take in input? Nothing. Okay, great. We can say parking floor two. So we have created our second parking floor. Okay. Now we have some parking slots. So let's say we are creating multiple parking slots. Okay, parking slot. So we have to give the parking slot type. So let's create one for car. So parking slot type dot car slot. Okay. Then we have parking slot. So we will create four parking slots. Okay. So parking slot type dot bike slot. Then parking slot three would be our truck slot. And then let's create a one more, and this would be for car. New parking slot. Parking slot type dot car slot. Okay. So we created four parking slots. Now what we would do is we would add parking slot one and two to parking floor one. Okay. And we would add parking slot 3 and 4 to the parking floor 2. Okay. Add parking slot. Okay. So for add function, we have made it boolean. Actually, we don't have to make it boolean, but anyways, right now it's fine. And then we say parking lot dot add parking floor, and we add these parking floors there. Add parking floor 2. Okay. So now about parking, we have created the parking. Okay. Okay. One thing which we forward in is the rate. We have to calculate the payment, how much a vehicle would pay. Let's just write it here. So till now our parking slot is created entirely. Now let's say car one comes, new vehicle. It would have a license number. Let's say license number is AA123. Okay. Vehicle type is a car. Vehicle type dot car. And parking ticket. Now this is where we did a mistake. When we are creating a vehicle, we don't need a parking ticket. A vehicle can exist without a parking ticket, right? So we can send null in here. We can send null. So we have set the parking ticket as null. Okay. So when the car would enter, we would generate a parking ticket for it. Okay. Give me 1 minute, I'll think through it. So one thing which we have to do is basically we inside our vehicle we can give a setup function for parking ticket. Okay, public required set parking ticket. So set ticket parking ticket. So this dot ticket is equal to parking ticket. So basically what I was thinking is that one approach would be we can create a function which is something like an entry function, and when a vehicle enters, we create a parking ticket and return that ticket via that function. Okay, so we can do that. Let's say I'm doing it here itself. Okay, it would return the parking ticket. Okay, vehicle entry. Okay, and here we would see which vehicle is entering. So we would say if now we have to figure out if we have an available slot for this vehicle type. Okay, okay. So vehicle type is equal to vehicle dot. Okay, we have not included the data set function. So let me just add the data function for vehicle type. Data function vehicle type. Yeah. So dot get vehicle get type. Okay, so this would give me something like, you know, so I have to see whether we have an available slot for a car. So what we will do is, what we can do is, okay, so what essentially, basically, if we go here now, we implemented the available spot, but we also should implement something which will tell us if a slot is available for a car, right? Here it is only checking if a slot is available. So let me add another function which would be public boolean check slot available. This would be for, this would take in a vehicle type, okay, and we would check for this vehicle type, do we have a slot. Now this is something honestly we should not be doing in the interview, we should have thought this through earlier. Right now that's fine because we are practicing, okay, so we should have kept this in mind. So we have to check if parking slot dot is available and parking slot dot, so basically we have to figure out parking slots type, right? So okay, let's go to the parking slot. In here we have a parking slot type. So for slot type also let's just use car, bike and truck for simplicity. What is the problem? Okay, this is one that we can handle. Let's come here inside parking slot type. Here I'll add a getter. Let me add a getter for type. Okay. Now here I come. Here I would say parking slot dot type get type equals vehicle type. Sorry, vehicle type. Yeah, because they are two different, event types. That is why. So let me do one thing. We can have the same enum, right? We can have the same enum for both parking slot and vehicle type. Basically, parking slot would be for a vehicle type only, right? So let me just remove this thing. Okay. And now we could only maintain vehicle type. So let me go to the parking slot in here. I would say find this and replace it with vehicle type. Replace it. Yeah. Okay, this is fine. Now here this is fine. Now here let's go back. Here I would say if it is available and if its type is equal to vehicle type. Now totally fine. We would say return true. Otherwise we will return the false. Now what we have to do is we have to return the parking slot, right? We have to return the parking slot, public parking slot. So we would say return parking slot. Else we would return. Sorry. Yeah. Now here I can add this stuff as well. So parking slot available, and then we can give parking slot dot get ID. I haven't implemented get ID. Can implement, but anyways it's not required. Okay, so let's just avoid this thing right now. So we have a parking slot available, and we can assign it get slot available. So this we have implemented on the floor, so we need a similar implementation for the entire parking lot. So let's come here, and in here I would say parking slot check slot available. So we would iterate through the parking floors. And here we have parking floor. Yes, this is the parking floor. So if parking floor, if parking floor, sorry, basically we have a vehicle type, right? Inside here we are sending this. So yeah, that's what I do. Parking slot, parking slot is equal to parking floor dot check slot available for this specific vehicle type. Okay. So if parking slot is not equal to null, we would return the parking slot. Otherwise, at the end, we have to return that. So now we can use this function in our main method. So main method. So let me remove this parking slot type and make it vehicle dot vehicle type. This will be yeah. Okay, this is fine. I think this is fine. Now, where were we? We were writing this function. Yes, we have to return a parking ticket. So now we are checking if so we're checking parking slot. So it's saying, uh, you know, we're checking it for the parking lot, right? So we need the parking lot as well. Or we can actually implement this there itself, but let's just try it here. Parking lot dot check slot available for this vehicle type. Okay. So parking slot is equal to null. So no slots available and we return none. Otherwise, what we do is we assign this parking slot to this ticket. So what we do is parking slot dot set with parking slot. I'll have to mark its status available as false. I need to set a function setter available false. So here I can write parking slot dot set available false. Okay, and now this parking slot is in use. You can create a parking ticket. Is equal to parking ticket, new parking ticket. When we are creating a parking ticket, okay. And we would assign this parking ticket to the current vehicle. So we will say vehicle dot set ticket parking ticket. Okay, we will return the parking ticket. Okay, so parking ticket is assigned to the vehicle. So in here, what I have to do is, even if I don't return this, it is fine totally. So we can just make it void, and let's keep it like this only. Say parking ticket is equal to car1 dot sorry, it's here it's open, so we will have to say vehicle entry parking lot car. Okay, so we have entered this car. Now we have handled a major part. So we are creating the ticket. Parking ticket is not created. Now when the car would want to exit, we will call the exit vehicle exit, right? So let me also prepare a vehicle exit. Let's start a vehicle exit. Void. Okay. We have a vehicle. We are marking its exit. Okay. For each of the vehicles, do you think we would need a basically when we are marking an exit, we would have to empty the slot as well, right? Where it was present, where this vehicle was parked. Vehicle would also have that slot, correct? It have a slot. Sorry, parking slot. Okay, initially it can be null when we are creating the vehicle, but in here, basically I'll need a setup for this. For insert setup. So in here I would say vehicle dot set parking slot. Okay, this is good. So now here we are saying, okay, our vehicle is now exiting, right? So vehicle is exiting. Let's free up the slot. But I need a getter as well, right? I need a getter as well. But insert getter for both vehicles. So yeah, parking slot, vehicle, okay, parking slot. So let's say parking slot and set available to, because now it is available. Okay. This because the vehicle is now exited. Now what I have to do is I have to calculate the rate. The double payable amount. Payable amount is payable amount. Payable amount is determined by the vehicle. Vehicle type basically. So let's say vehicle type is vehicle dot get type. So right now I'm just let's just say double vehicle rate. Okay. Switch so type sorry type dot string equals so vehicle type will be car. Right? So let's look at case. This one is a case car. Okay. Case car. Like this. Yeah. So if it is a car, we would set vehicle rate to 10. That's it. Case bike, it would be 5%. Case truck, it would be 20 by 0. And we break, and we break. Default, south, invalid type, invalid vehicle. What is the issue? Okay, so sorry. Yeah. Okay. Now default okay, this is fine. So now we would say payable amount is equal to vehicle rate into the duration, right? Now we have to also calculate the duration for which the vehicle was parked. So we would get the duration from its parking ticket. Let's get the parking ticket. Parking ticket is vehicle dot get parking ticket. Parking ticket. We are not given the data function. Get ticket. Okay, sorry. Get ticket. So we are saying local date time now is local date time dot now. Let's should calculate it as soon as we are setting it available. Okay. And it was issued at local date time parking ticket issue that parking ticket got letter or insert letter for issue that. Okay. Also, we will have to set the status. So, alt insert setter for the status. Okay. So now parking ticket is able to get issue that. Okay. So now duration was now minus when it was issued. Minus cannot be. I think we have a function to calculate the duration. Let me quickly check that out. Get duration. So okay, we would say duration is equal to duration for mean the parking ticket issued at then now. Okay. So now whatever R we have, that is in sorry, whatever date we have, that is in hours. So we'll say duration, but let's say yeah, that's hours. So let's say duration of okay, vehicle rate might not have been initialized, or has been initialized, or might not have. So we will just check. Or let's say for default, right, we would give a vehicle rate as something like I don't say this is okay. So now this is the payment amount. So now we would also take users input scanner receive no scanner system in okay. So we would say something like payment type. We would say cash or okay. Okay. So now what we expect? So basically we would say string payment type is sc dot. We will take the string input. Okay. Let's take the string input. Okay. Now if payment type dot to lowercase payment type equals cash. Okay. Then what we will do is we will call the for payment strategy we have implemented the pay method, right? We will create payment is equal to new cash payment, and we could say payment strategy dot pay via payment, and the amount is payable amount. Okay, else let's default to UPI payment. Okay, UPI payment strategy payment payable amount. Yeah, obviously there's a better way to write it, but let's just write it. Basically I'm also trying this problem for the first time, so this is how we would think of it in an interview. Okay, so this is code. So vehicle exit when written the function. So let's say I will just simulate some waiting time. So let's say for the sake of this problem, let's say that our payment, or let's say vehicle rate, it is in seconds. Okay, so that we can simulate a situation right now. Let's say millis. Okay, now here I would make a thread sleep for 1000 milliseconds. Okay, this is okay. Yeah. Now what this, we would make the car exit. Car 1 dot, sorry, vehicle exit. Car 1. We will make it exit. Okay. Any issues? Let me run this and check. How's it working? Okay. Let me run this. It's building. I realized the last line is not visible. That is why. Let me just bottom this. Yeah, it's building. Anyways, let it be. Once it is built, we will be able to run it. What happened? Is there an issue? Build is in progress, I think. Yeah, so you can see this build status. Okay, here also it's buffering. It's buffering for too long. What is happening over here? Okay, executing 3.5 tasks. Let's see. Okay, it's built. There is one issue. It is asking for payment type as soon as it started. So basically, okay, so basically the car and all the thing is done, and now the car is exiting because for none of the above stuff we have taken input from user. Okay, anyways, that's what happens. Processing payment, cash payment of amount 10. Okay. Okay, so this is basically working, but let's make it a more, uh intuitive. Basically, let's take the vehicle and all input from users. Okay. So should we already handle that? Or let's do one thing, let's simulate other stuff as well. Okay. We have created and we exited this car. Let's also create another step. Let's create a bike and we would bring a bike 1, 2, 3. Bike would be of vehicle type bike and ticket is null. I don't know. I don't have to actually store this anywhere. I'm not using this ticket, right? So we could just say vehicle entry. So a bike has also entered. Okay, let's say a bike is also entered. So let's do one thing. When we have entered the vehicle, at the end we can add a log verify that this vehicle has entered. Okay, so let me add this out. Vehicle with license number. Again, I have to add the getter for license. I have not added, right? Get a set of functions, we should just have it. Yeah. So here we say vehicle with license number, vehicle dot get license number, entered the parking lot. Okay. So we have entered the vehicle and enter the parking lot. Let's also mention the time at park ticket dot get issued at. Okay, so we also have the time. When did it enter? Other than that, we should have something else. I think no, we are good. We are just saying that okay, vehicle has entered at this time. So when we run our code, we are able to understand. Now we are entering this. Now when we created only one slot for bike. So let me also try adding another slot for bike. Let's come up with another bike 4, 5, 6, and let's see if we get a valid error message. Type dot bike. Okay, actually, this null we should avoid writing. So let's do one thing. Let's go to this and let's remove this. It's not required. Let's avoid it. Okay, this is good. And here we would remove these occurrences. Okay. Yeah. Now this is good. We have entered. Okay. Now vehicle entry parking lot vehicle by 2. Okay. So yeah. So we have inserted all the bikes, basically both the bikes and the car. And okay, we are waiting for 1000 milliseconds just to give a wait, making a wait of. So let's do one thing. Let's do one thing. After the first car comes, let's make the thread sleep for 20 milliseconds. After the bike, after this bike comes, let's make the thread sleep for like 1000 milliseconds, which is basically a second. Here also let's simulate 2000, and here we would here let's sleep this thread for 3000 milliseconds. And after that, we perform exit for vehicle car 1. Or let's say when we perform exit for vehicle exit car 1 after 3 milliseconds. Let's simulate this for 5 milliseconds and division let's calculate it for second per second. Okay, seconds. Okay, so vehicle exit car 1 exit. Okay, let's just keep it here. Also, yeah, I think this is good. Let's run this. It's building. Okay. So here we can see vehicle with license number of A1 enter the parking lot. Wait 42. After 3, we have added some sleep. After some time, this vehicle with this vehicle enters. For the third vehicle, we are getting this error message that starts. Then we are trying to exit. Car 1 is trying to exit, so we can provide the payment type cash, and they process the cash payment of amount because for car the weight was 10, right? Yeah, so it was there for like 10 8, 8 seconds, I think. Yeah, 2 plus 5, 2 plus 1 plus 5, right? Yeah, so this is the basic implementation. The code. So we've implemented 2 design patterns. One is strategy pattern for payment, and another is singleton pattern for parking lot. Okay. There are few improvements and few changes which we made to this design. But in this, that's it.